So now look at this example here. As you can see, when I push this button, every time when I click it, it turn on and turn off. But sometimes, as you can see, I just click once, but it blinking. It just like blinking like that. Sometimes it happens, sometimes it's okay, sometimes it blinking. Why this happening? This is basically what we call a switch bounce or bouncing, which actually refers to a button's tendency to turn on and off several times after being pressed only once by the user. This phenomena occurs because we know these buttons is mechanically constructed by using a spring inside there, which actually it can make them vibrate whenever we release or whenever we push the button. Since we know the spring will somehow sometimes will go up and down, and that's why it just like it changing states from high to low, and this sometimes will cause wrong behavior of digital circuits due to reading multiple values for a single press of a button. It might give you a wrong warning message, especially if, let's say, you want your system to send message to you, and then when it trigger high and then trigger low automatically, it might give you some different idea, somewhat wrong warning message to you, and we don't want this. We don't want this false trigger, and that's why we need to remove this condition here. So how to remove this condition here, all will be discussed in this video after this. So to understand about the switch debouncing, we can look at these waveforms here. As you can see, ideally we should get this waveform. Whenever we turn on, it triggers high, it will directly triggers high, and then when it goes to low again, it will directly go to low. But somehow when we use this kind of push button, it is not directly go to high. Sometimes it will go to low again because of that spring, and then it will go high again and low again, and then it start to become stable, then it will reach the high, which is it is turned on, which means that it takes a few bits of times before it turns on. And also when we want to turn off, it always changing like this. And because of this condition here, if we want to remove this, we need to know what happens in the previous state, which means this is the previous state, and then what happens in the current state. So if the changing is too fast like this, it's too small like this, which means since this is against time, which means if it is too low or just happens too fast, which just less than about 5 milliseconds here, or 10 milliseconds, which is too fast, meaning that it is actually not a changing state yet. In other words, although it goes to high and then suddenly goes to low, it is not changing state yet, meaning that if the LED turn on and then suddenly it goes down, it will not turn off yet. It will wait for a while. If after that it get to high again, it will remain as high. Only if it goes low for a longer period of time, then it will turn off, meaning that it will wait for a while. After it change state, it will wait for a while before it really change the state. In other words, after we push the button, it will wait for about 5 milliseconds or 10 milliseconds before it really turn off, so that it knows that it is just a debouncing. It is not a real pushed by the user. So this is what we do. This is how we do it, meaning that we will wait for a while, therefore there will be a delay in our coding, and then we will store this previous condition so that we can compare previous and current condition and check the time between it. If the delay or the time between it is more than 5 milliseconds, then it will change the state. If the time is less than 5 milliseconds, it will stay at that their current state. So this is what will happens in our coding, what lines that we will add in our coding. So if you understand this condition, let's move on to our Arduino coding. So here is the Arduino coding that I made for the button, that the toggle switch that I showed in the previous video. So last time I give you the challenge where when we push once it turn on, push once again it turn off. You don't need to hold the button to make it turn on, just push once it will directly turn on all the time, and push again it will turn off. So this is actually the answer to that challenge, where again I have already showed the flowchart, so you can open up the flowchart, which here in this coding we check the current condition, and then we compare last and current. If the current is low and there are change between the previous and the current condition, then the LED will if the LED on, it will turn off. If the LED is off, it will turn on. So as simple as that. So this is the current this is the programming or the coding for that challenge. So you may, if you don't get the answer last time, or if your coding is slightly different than this, so you can compare your coding, see which one is the best solution, the shortest solution, and try to again, if you don't have if you don't get the answer last time, you can try to do this coding here. So now again, if you want to have some time, take some time, you can pause this video. But if you already got the answer previously, then you can continue with this video where I will add the coding that I showed in this parts here just now, where we will add these conditions in our coding, which we say, or which we want to remove the debounce problem. So here is what I want to do in this coding here. Instead, I don't want to really mess up with this coding, so I don't want to add all this coding inside the void loop. Instead, this is one more tips. If you have a complex coding, the best thing is you do it in different function, which means I will construct other function that is out of the void loop, so that the void loop codes is not too long, which again, this will be helpful to you for our second assessment. I did not assign second assessment yet, but this kind of conditions will be helpful to you for our second assessment. So that's why try to practice what I want to show in this video. So again, I want to make one function here, so I want to make one function here under the void setup here, or maybe under the void loop, anywhere you want to put it. So you can this function it will return the boolean comparison, instead of void actually does not return any value. So I want to return value from this function here into the void loop. I want to transfer this function data into the void loop, so that's why I want to give some values. But what kind of values? There are several values. It might be integer, so integer, so I will define int. If I want to return character, then I will define char, and so on. But now I want to use the boolean which I will name it as debounce, which the data that it will transmit or that it will return to the loop, the void loop, is basically the boolean information of the last condition, the last condition, because we want to check the last and the previous condition, is it changing, is it changing. So meaning that from here, from the void loop, it will take this last value into the into our debounce function and then return some value after that. Okay, so here is our function. Our function, again, you just need to enter and automatically it will come out with this another curly bracket. You don't need to write both curly bracket. So what happens here, what we do is basically we will check the current state. Why I write boolean here is basically this is just like before, is the initialization, is the declaration of variable. So variable last is basically a boolean variable, variable current is boolean variable, not integer, not character, not float, not double, not long, just boolean. So basically what it will check is the digital read from the pin 3, or the button. I have already defined button here as pin 3, so that's why I just write button here. So it will read from the pin 3 the current condition, and it will check if the last condition is not equals to the current condition, meaning that there are change between the current and the last condition, meaning that there are changes. If there are changes, then what it did, it will do this steps here. Again, from here we know if there are changes current and previous, if it does not exceed 5 milliseconds, it does nothing. It will not change the state. It will not turn off the LED, or it will not turn on the LED. So meaning that it will wait first. So wait first for 5 milliseconds. So again, this information here is in millisecond, so it will wait for 5 milliseconds and then it will go to the next part. So what happened after it wait, it will recheck again, read again, it will recheck again this same pause, it will check again. So is there any changes? So it will check again, so is there any changes? If there are really change, if there is no change after that, meaning that after it goes low, it remains low after 5 milliseconds, meaning that the state is really changing, it is not bouncing. If it keeps changing, then it is a bouncing. But when it turns low, it remains low, meaning that after 5 milliseconds it remains low, meaning that the state is really changing. So because we know it is really changing, so we return this value, this current value, into the void loop function. So meaning that this one is returning the value, return current condition to the void loop function. So that's it. That is the coding. When we did this, actually we have removed this bouncing, this button bouncing function, but because we already checked the digital read in the boolean in this function here, so we don't need this anymore. But instead, what it does here, for this part here, we change so that it goes current condition, it goes into the debounce function with this variable. Yeah, what happens here, the current button, it will goes to this boolean function, and then boolean will check the button's condition from the digital read, and then it will check is there any changes, and then it will return current. This current will return to this function. So meaning that now these values here, it will check if there is a really a changing state, then it will write the LED again. Okay, so now if you don't understand it, again I repeat, what happens here, this if it wants to check the current condition of the button, it goes to this boolean function. So boolean function will read from the port 3. So from the port 3, it will wait if there is a change, if it will wait for a while, for 5 milliseconds, and then if it is real after 5 milliseconds, it remains that condition, then it will say yes, there is changes. So because there is changes, then it return this condition into the void loop again, and this value here is what is being read in this next parts, next lines of code. So instead of we write everything here into our code here, we write it in a separate function. And because it is in separate function, as you can see, I did not need to mess up with my previous coding before. So I just need to add this function only, and then just change one line in my original coding. So I did not to change everything. So as you can see, it is much easier, it's much neater, much simple compared to if I add everything inside the void loop. And that's why I suggest you, if you have for the project, especially if you have a lot of complex coding, a lot of comparison you need to do, so the best thing is you provide these functions here. So make it another function so that your void loop is remain clean and clear. Okay, so now we have the coding, everything is done. So should be, if we try to upload it, so it should be working. So as you can see, okay, so there is no blinking anymore. Yes, there is no blinking anymore. See, everything is nice. So how fast I click, it still remain, it's not blinking. So which means that the debouncing has already been removed from this button, this coding. And yes, we finally have been able to produce a better output compared to the previous coding. Try to apply this in all of your digital sensors, especially if you use this push button in your project, so that it will never trigger pause outputs. So that's why, again, try to apply this knowledge here for your project later on, and for the second assessment later, the third assessment later. And I hope that this example here is helpful to you, and as usual, if you have any problems, just ask me anywhere, in private message or in the group, and also in the comment down below. And as usual, if you like this video, click the like button and don't forget to subscribe. And that's it from me. Thank you very much for your attention. I'm Ikhwan. May God bless you. Assalamualaikum.